Hey there. Thank you so much for joining. We're going to start the webinar here in about a minute. We're going to wait for some other folks to join. And as a reminder for the participant in today's webinar, we'll be taking questions at the very end of the webinar. But if you have anything that you're inspired by the content we're presenting today, please feel free to punch those in the chat. And we'll go ahead and take those questions at the end of the webinar. We'll begin here in about 15 minutes. Okay. All right, Pratik, are you ready?
Let's go.
All right, let's dig in here. Okay. Hey guys, thank you so much for joining us today. We're taking a look at a report that was recently published by Azul's Java Performance Benchmarking Lab. The report measures and quantifies the performance capabilities of Java runtimes available on the market today. My name is Anne Plessé. And as a part of my role here at Azul is I work with our customers to help them get more value out of our high performance Java runtime, or that's Azul Platform Prime. They use Prime for their business critical applications or revenue generating applications. So performance is really important to these customers. With me today to unpack the report is Pratik Patel. And Pratik runs our developer relations organization. So Pratik, over to you for a quick introduction.
Yep. Thank you, Anne. So my name is Pratik. I run the developer relations team at Azul Systems, and I am a Java champion based out of Atlanta and have worked on many large-scale Java performance deployments in the past and currently. So something right up my alley and, of course, Azul's alley in terms of high-performance JVMs.
Awesome. Awesome. So lots of wisdom is going to come from you today. So, all right, guys, we are going to spend our time breaking down 3 areas. So number 1, we're going to contrast how OpenJDK compares to Azul Zing builds of OpenJDK. So I'm going to have Pratik do a little bit of a technical breakdown so you can understand the difference and what makes our runtime special. Now, Azul Zing requires no code changes or re-architecture to deploy. It's pretty easy, but there's a couple of bits that we switched out which make it more performant. So Pratik's going to break that down for us. Number 2, we're going to share the key findings from actual performance tests from our lab. We're going to specifically shine a lens on Java 17 and Java 21. Now, if you're looking to migrate or upgrade to Java 21, the test results and the data would be really important to include in your cost-benefit analysis. As a matter of fact, the entire report is really important resource for you as a part of that effort. And then finally, my favorite part of our presentation today, that would be the actual case studies and use cases from a customer base of how they use Azul Platform Prime to improve customer experience and site reliability. Azul works with global world-class SRE, cloud architects, and performance engineering teams from around the globe. We're going to surface some experiences they've had with our runtime because they serve as a very important feedback loop to our performance engineering lab in terms of how we push the performance limits on Java. So before we dig in here, I just want to remind our audience that throughout the presentation, everybody's on mute, but if you have a question, please do punch that in the chat and we'll have some time at the end for Pratik and I to address those questions. So with that said, let's go ahead and dive in, Pratik. Over to you.
Yep. So if you're not familiar with how JDK looks and how it's assembled, there are 3 major parts of it. There's the actual OpenJDK JVM, which includes things like class loading and initialization, things that you're familiar with. And then underneath that, we get into more of the nitty gritty. We have the heap and the stack, native memory. And then underneath that, there's execution engines. There's the interpreter, the JIT compiler, and different garbage collectors, all of which we'll talk about in just a second. So this is how overall OpenJDK looks. And all of Azul's JVMs, Azul Zulu and Azul Zing, which we're talking about here, are built on OpenJDK source code. So we are 100% compatible with any Java app that you're running on OpenJDK because we build from the same source. But what we do is we substitute out some of the things at the bottom layer to get increased performance in Azul Zing. Okay, go to the next slide. And so what are those specific things that we go and improve upon from OpenJDK. So one of the main things is that we have our own JIT compiler called Falcon. And what it does is it more aggressively goes and optimizes your code. So you're probably familiar with what the JIT does. The JIT looks at your code, and as you're executing it, it goes and finds things to go faster, basically. So an example of this is something called method inlining, where it's able to go and see that you've executed a specific method many, many, many times, and you're always getting back the same result. So it will go and inline the method so that you don't have to pop that onto the stack and then unpop it from the stack, i.e. it's a low-level performance enhancement. So we have lots of these things. So the method inlining specifically is also in OpenJDK, but we have more advanced things in our JIT compiler. It's more aggressive at optimizing your Java code than the JIT compiler that's in OpenJDK. So one of the caveats that comes with that is that Azul Zing will take a little bit more time to reach peak optimization, but it's totally worth it because, again, it does a better job of optimizing your code, so you see better performance gains and more stability over time. Okay, so along with that, we have our own garbage collector called C4, which is a pauseless garbage collector. So that means that you don't have to worry about GC pauses when you're running your application. So there are, as you're probably familiar, garbage collectors which pause, what's commonly referred to as STW, or stop the world garbage collectors, which essentially freezes all execution threads in the JVM while the garbage collector is running. Our C4 garbage collector does not do that. It continuously runs in the background and is freeing up memories for your application to continue running. Right. And we'll talk a little bit more about some of the other enhancements we have, which are not necessarily baked into the JVM, but are additional tools that you can use with Azul Zing to get even better performance, lower CPU utilization, etc. So the thing to note again is that Zing is built on OpenJDK, so it's 100% compatible with whatever you're running with your Java application, right? So we already talked about the Falcon JIT compiler. It allows faster application execution, even compared to the standard JIT in OpenJDK. We have a pauseless garbage collector, which means that you get more consistent performance and more consistent lower latency. Also gives you the ability to have more headroom. And then one thing that a lot of people don't know about Zing is that it also has lots of low-level runtime enhancements that go all the way down to the CPU level in some cases. So we'll look at in just a second the different things that we include in Zing, which are like low-level optimizations, all the way again down to the CPU instruction level, as well as the operating system level. Okay, and we'll talk about the Ready Now warm accelerator in a couple of minutes. But the key thing to note here is that this is not 100% brand new JVM. We build on the OpenJDK source code so that you have the confidence of running your application and easily migrating from OpenJDK to Zing without having to worry about any incompatibility issues. It's, as they say, it's just going to work. All you have to do is swap it out. And there is some, so there is the possibility that you have to do performance tuning, but the way that we have built this high performance VM is heavily based on customer feedback. And in one of the case studies, we'll talk a little bit about how one of our customers actually was able to reduce the amount of time that their engineers spend doing low-level JVM performance tuning, because Zing just does it for you. It's baked into the VM, right? So, and as you can see at the bottom bullet right here, we see an average of 37% performance boost compared to OpenJDK distributions. So let's kind of look at the different versions of the JVM and how the performance improves. So again, the Azul are the JVM performance experts. We have a dedicated team of 50 plus people working every day to improve performance in the VM. And we have a very thorough test lab where we test all sorts of different things. For example, we test big data frameworks that are commonly used: Apache Cassandra, Apache Kafka. You may be using something even like Airflow. So all these different things we test in our lab, and we see how the JVM responds under heavy load when you're running these big data platforms. And we go and optimize the JVM to make those things run faster. And that means that your code will also run faster. And obviously, we do lots of other optimizations. So the second bullet here on the right is the customer applications. So we actually either test on the customer's infrastructure or in our own test lab a customer's application, and the insights that we get from that we take back to engineering and make more performance enhancements. So, and as I stated before, we have lots of low-level JVM optimizations down to the operating system level, down to the CPU level, and of course, JVM internals. We talked about the Falcon JIT compiler, which of course is a JVM internal component, but there are other optimizations as well. Now, one of the things that we pride ourselves on is that we don't just focus on a single architecture. We look at x86 and ARM64, for example. So that means that if you're looking at cloud cost optimization for your Java workloads and you're thinking of going to ARM, well, we got you covered on that front too. And we'll look at some numbers, hard numbers in just a minute, to give you an idea of what that looks like. But we talked a little bit about like kind of CPU optimizations that we take advantage of to make the JVM run faster. For example, on x86, specifically Intel, there's LAM. So we're constantly looking at what are new features down in the CPU and CPU chipsets that we can use to make Java run faster for you without you having to really do anything. Okay. And of course,
That's a
there's
good
things
point.
at the Linux level also. Yeah, go ahead, Ann.
Yeah, that's a good point. And I wanted to zero in on that too. So there was an announcement by Intel. They actually shut down their granulate division, I think earlier this month. Pratik, and as you're talking about the hardware capabilities and CPU architectures, we have received a couple of inquiries from the customer base and granulate customers, and we do have a special offer. So for those looking for commercial support or looking to transition away from granulate technology, it's very similar because it does optimize the runtime. So we are offering a free performance and benchmark test for those customers. So if you find yourself in that situation, I just want to do a little bit of a shout out, Pratik, because that was a
Yeah,
little bit of a wrinkle in the market. So I'll go ahead and throw it back to you, Pratik. But
sure.
yeah, if you are granulate customers, this is a really good alternative for you. Yeah.
Yeah, absolutely. So, okay, let's go to the next slide and talk a little bit about how the JVM that we make is faster. So we spend, as noted on the previous slide, we have engineers working full time to make the JVM run faster every day. And the questions that we ask our customers, or they come to us with, is how can we accelerate startup? How can we make your JVM start faster, especially for larger monolithic type of applications? How can we make the JIT better? What are more optimizations can we do? And so when we work with customers, we look at how their code runs on the JVM, and we take that knowledge back and make the JIT better for everybody, all of our customers. And some of the other things we look at, as we know, whenever we run a load on any application, is what's the peak performance and how do we make it faster to get to peak performance? How do we avoid JIT warm-up time, right? So that's what these add-on tools at the bottom of this slide are about. So Ready Now is a tool that we have that allows you to reach peak performance. So instead of having that JIT warm-up phase where the JIT is, number one, consuming a little bit of extra CPU as it looks at optimizations that it can apply and rewriting bytecode on the fly, as well as your application in general as it's running and it's starting to do its work, you get a little bit of extra CPU utilization until the JIT does those optimizations. So you kind of hit a little bit of a peak just at startup before the JIT reaches optimal or near optimal efficiency. Now, the time that it takes for that varies very widely from application to application, but for a small application, it could be on the order of seconds or minutes. For medium-sized application, let's say 10 or 20,000 lines of code, that can take 5-10 minutes. For a larger monolithic type of application, the either the OpenJDK JIT compiler or Azul's Falcon JIT compiler can take 20-30 minutes to reach peak optimization. And during that time, while it's optimizing your code, your app is still running, and obviously, so you're using more CPU. How can you avoid having that little bump when you start up before the JIT optimizes your code? Well, that's what Ready Now is for. It allows you to basically plug in a pre-optimized JIT metadata directly into your application when you start it. So you don't have to have a curve that goes up and then kind of flattens in CPU utilization. It will reach peak CPU utilization right away. And along with that, we have something called Cloud Native Compiler, which allows you to run a single JIT compiler in the background and feed optimized JIT metadata to running applications. So the use case here is, say you have 10 nodes in your Java application cluster, or 100, or however many. What you can do is you can have one thing, which is our Cloud Native Compiler, that sits in the back, looks at the optimizations that each of the individual nodes in your cluster might be doing, but you're only doing it in one place. So you're using less CPU across the board. You're basically doing those optimizations once and then feeding them to the running JVMs that are running your application, right? So that's a very exciting tool for people who are doing even small to medium-sized deployments, because you save a lot of CPU overhead by doing that. And then Azul was the pioneer of something called CRAC, which allows you to do instant JVM startup. And this is actually code that we contributed back to the community and back to OpenJDK. So we are leading the effort in making CRAC or crack something that anybody can use by contributing back. It's our contribution back to the OpenJDK ecosystem. But these are the three kind of add-on tools that allow you to get better startup performance and better performance at runtime right out of the gate. Okay, so let's head to the next slide. All right, so let's talk some numbers, right? Because everything we talked about was great, but what does this actually mean? So one of the things that we see with our customers, and we talk to our customers about, is just, for example, from going from OpenJDK 11 to 21, again, just OpenJDK, you'll see approximately a 12% improvement in baseline performance. And that's because every release of Java, of the OpenJDK, gets better, right? There are optimizations that are applied down at the OpenJDK level, and numerous other things. But we keep up with all those updates, obviously, and we add extra things every update. So from going from OpenJDK 11 to 21, again, OpenJDK 11 to OpenJDK 21, you'll see a speed improvement. But if you go from OpenJDK 11 to Azul Zing 21, we see in our test lab and our customers see in their production applications 36% improvement in baseline performance. So what I tell our customers is, look, if you're going to go from Java 11 to 21, it's a great time to have a look at Zing. You're making a transition anyways to a new JDK, so why not try us out and see if we can get even better performance while you're going through the motions in the process of upgrading your JVM, possibly upgrading your code. Maybe you're using it's sprinkling in some of the new JDK features like the records API and things like that. While you're doing all that stuff, try us out, right? And again, it's a drop-in replacement for OpenJDK, so you don't have to do anything special to use this. You just basically install Azul Zing like any other JDK, and you're off and running. So, and we detail all this in our high performance Java benchmark report, which we're going to drop a link into this, and we can also send you afterwards. Okay.
Yeah, exactly. So we already punched in the link. Pratik, thank you for going through some of the technical details and how we deliver the performance gains. So what I've learned from you so far as we transition to understanding how our performance lab works and the customer use cases is, if you look at Zing, it's been deployed very broadly and widely across many different industries. And Zing actually loves digital workloads. It loves Java workloads that have a performance SLA attached to them. But the benefits fall into really three categories, Pratik. So number one is stability, more stability for your application, less performance tuning and effort. Number two, additional carrying capacity, which we're going to see ultimately reduces CPU consumption. It can help you reduce cloud waste. And then finally, consistent lower latency. And when you and I talk to our customers, these are three themes, right? And these actually, if you look at the benchmarks we published from our lab, those are the three North Stars, if you will, that our performance team actually benchmarks against, and making sure that we consistently over time improve upon those things. So back to you, Pratik.
Yeah, so one thing I want to comment on these 3 points is that if you're a Java developer, and especially if you focus on performance for your Java applications, you know that these 3 things, stability, the ability to have more load on the same application running on the same infrastructure, and lower latency are all things that go hand in hand. So when we say more carrying capacity, we mean that you can push your JVM harder and still keep low latency, right? So obviously with any application, you can overload the application, right? You push your application, your perf lab, you push it, you push it, you push it, you find what the breaking point is, and then you say, okay, this is about how much load we can carry on this one node or across this cluster of nodes. With Azul Zing, what we see both in our test lab and with customers is that the basically the peak load that you can handle, again, just by swapping out OpenJDK to Azul Zing, is much higher because we have all the enhancements that we talked about. We have a JIT compiler called Falcon that does more aggressive optimization of code, i.e., that means your application will use less CPU as it optimizes code. Our garbage collector is very efficient, pauseless. So you get lower latency. You don't have outliers in your latency because of garbage collection pauses. And then, of course, those two feed directly into the stability of your application. So when we look at these case studies, you want to keep these 3 things in mind so that when you're thinking about your application, how it's performing, you see during the day, right? Like maybe early morning, you don't get a lot of load, but as your customers or your users come and start using your application, the load starts to go up. How much load can we handle? Do we need to add more capacity, whether by adding more CPUs and memory to individual nodes or by adding more nodes? If we can just run on the same infrastructure and have that safety net that Azul Zing provides with being able to get pushed 10%, 20% more load, maybe more, through the existing infrastructure, it helps as both a DevOps person and as a developer, knowing that Zing is able to handle those higher peaks and not cause high latency, which obviously is problematic, or worst case scenario, your application or your application nodes just aren't able to service requests because they're overloaded. So, okay. All right, so let's look at a case study of LMAX. LMAX is in the FX space, and what they have seen, and we work very closely with LMAX, right? So again, I've stated before that we work closely with our customers so that when one specific customer uncovers a performance issue, we're able to take that and bake that into our Azul Zing JVM so that all the customers can avail of that performance enhancement or whatever change that we make here. But they've seen, since they started working with us, a 48% faster performance over OpenJDK. And they are able to process 800,000 orders a second with their infrastructure. And again, they can push it and push it and have that kind of, this is obviously a trading kind of application. So for them, latency is something that's extremely important, as is for anyone working trading applications, fintech, financial services, et cetera. And we'll talk more about that latency in a minute with another case study. But 800,000 orders a second is like, I don't know, like a billion orders a minute or something. And
Yeah.
I'm joking, of course, but you get the idea, right? It's a lot of transactions a second and minute. So they are able to have this stable infrastructure because they're running on Zing, again, with all the optimizations and the performance tools that are baked into our JVM that we discussed previously. Okay. All right. So another one of our very large customers is a large global e-commerce company, which you're probably familiar with. And they have been able to see a big improvement on two fronts, both on the stability and low latency side, and also on the cost side. So again, by just swapping out OpenJDK with Azul Zing, they are able to reduce the number of servers that they actually need to run in production, right? And this is a little bit of an understated type of thing, if you ask me, because as a software developer, I care mostly about writing good code, fulfilling business features, and of course, making sure that things run smoothly on production. And one of the things that I see with our customers is when I explain to them about the extra headroom that they have when they swap out and put Azul Zing, our high performance VM in, you get a lot more confidence in being able to handle much more load. So you think about a scenario like Black Friday, when you have everyone getting up at 5 or 6 a.m. to go buy that, big 80-inch OLED TV or whatever, or whatever, all the things which are on sale on that day. So this company has to be able to handle that huge amount of load, and of course, still be able to have customers put stuff in the shopping cart and shop and have a good experience. So the other thing I look at when I'm considering what our customers want is they also want to have great user experience. When someone's clicking on your website trying to buy something, they want to be able to get through their shopping cart and buy something and go on with their day, or do whatever, right? So and this customer did a large scale transition, and they migrated over 70 Java applications to Azul Zing to avail of that stability and extra headroom and peace of mind, if you will, for being able to handle those high peaks. And as I stated before, no changes to code, no changes to their infrastructure. You drop in Azul Zing, take out OpenJDK, you point your Java app to the new JDK. And we could do this live right now in like 30 seconds. I could show you switching from OpenJDK to Zing if you all wanted, but we won't do that now. Maybe we'll do that some other time, or contact us and we can show you how easy it is to do that. So again, no code changes. And also, more importantly, you don't have to change anything in your CI or CD build pipeline to use this. You just change out the OpenJDK. So, all right.
Exactly.
So let's talk a little bit about Taboola. So this is an ad tech company, and again, their business is focused around filling ads as quickly as possible. So when you go to a website, you see an ad fill in. The most annoying thing ever is you're starting to read something and then an ad pops in. It changes like the whatever the layout of the web page is. So they want to get that super fast response time, and that's only part of their story. So when they swapped out OpenJDK for Azul Zing, they saw a 30% reduction in the server footprint they needed for that part of the application. And they also run their big data infrastructure, specifically in this case, Cassandra, to do queries again for ad fills for their ad tech engine. And they were able to push their existing Cassandra big data infrastructure, not exactly 50% more, but we have to do math to calculate that. But if we flip that coin over and think about how much infrastructure did they not need to implement for their, in this case, the database server footprint, that's Apache Cassandra. So they're able to actually reduce the number of Cassandra instances. Or again, if you think about the other way, if you think about growth, I can continue to run on the infrastructure I have and have a lot more headroom for growth without having to buy more servers or buy more cloud instances to be able to support that kind of thing. And again, Taboola is at scale, right? You can see the number at the bottom right, 500 million daily active users, right, per day. So it's quite a big platform. You probably have seen their stuff. They don't necessarily do the front part of the ads. They do the back part of the ads, ad tech stuff. So they're like a clearinghouse almost. But anyways, we don't want to get too much into what their specific business is. But to give you an idea, again, for both their application and also their big data infrastructure. So you might be thinking, well, we use other big data infrastructure. We're not using Cassandra. Okay, that's fine. We've had customers who have come to us and swapped out OpenJDK, for example, for Apache Kafka, and they see 20 to 30% improvement in throughput. Or again, if you flip that coin over, that means that you can, if you're running a 100 node Kafka cluster, you can probably dial that down to 80 or 70 nodes and 20 to 30% cost savings for running the same stuff with the same level of confidence, same lower latency, etc. Okay. All right. So one thing that we wanted to highlight is how is it that we do this, right? We talked about some of the kind of technical details around this, which is we have the Falcon JIT compiler, we have our own garbage collector, we have low-level optimizations that all make this an amazing VM for running performant Java applications. But there's a lot of work that goes into this. We have a large engineering team, as noted before, and we have world-class engineering lab that we test our own stuff in, our own applications, synthetic tests, real tests, etc. We also help customers test their stuff as necessary. We talked a bit about new hardware capabilities, updates on CPU architectures. So for example, when Graviton 4 came out in the last year or two, we went and implemented the new stuff that was in Graviton 4 so that Zing ran as best as possible for your Java applications, right? So we look at x86 improvements and ARM64 improvements, and we incorporate whatever is new in those CPUs instruction sets to make things run faster, right? And then, of course, we are at the forefront in helping to push different types of improvements in the Java, the Java virtual machine. We talked a little bit about crack, and there's other stuff that we do around there also. And of course, we contribute some of these enhancements and changes back down both into OpenJDK and into the LLVM compiler community. So Zing is built on something called LLVM. I don't want to get too much into that because that's getting a little bit on the kind of how do we do this? How do we build for multiple platforms, i.e. ARM64 and x86? So a little bit outside the scope of this. That's stuff that we worry about. It's so that we can build from a single code base and have two binaries for two different CPU architectures. So, but if you look at the chart on the right, you can see how we stack up over time with the different versions of the JDK, and you can see, that we outperform and have outperformed OpenJDK for a long time in terms of performance, OpenJDK versus Azul Zing.
Okay. All right. So I think we're coming to the conclusion of our presentation here. So again, for our participants, if you have any questions, please punch those in the chat. I haven't seen any questions so far, but Pratik, when you and I were talking offline before our presentation today, we kind of itemized a lot of questions that you and I get offline about Azul Platform Prime. And one of the questions that always boils up to the top is, hey, can I procure? Are you available on the AWS or Google marketplaces? And yes, we are. So, and that's really important for a lot of companies too that have enterprise discount programs or committed cloud spend, right? That they need
to. So one thing to note about this is if you are a sizable AWS or Google Cloud Platform customer, you typically will have marketplace cloud credits that are just part of your package deal that you make with AWS or GCP or or whatever. And so you can actually go and buy Azul JVMs or our next generation cloud tool called Intelligence Cloud. And you don't actually even have to spend any money, or you don't have to wrestle with procurement to get a new vendor in. You can go to the AWS marketplace, for example, and you can buy Azul Zulu, our build of OpenJDK, or you can buy Azul Prime. Of course, for Prime, you should come talk to us, and we can help you make the most of our high performance VM. And of course, we do that as part of just helping you to use our VM, but you don't have to spend any money because you probably already have some credits that you can just go and use. So
Exactly. So many companies are also looking to consolidate their software spend too. So that's a good part in service of that strategy. Also, we are a member of the FinOps Foundation. That is a framework for curbing, controlling cloud waste or cloud spend. So we actually just published a report to the FinOps Foundation that helps the companies and members understand how to use Java as a programming language to reduce cloud waste. So it's a step-by-step guide. That's been our most recent contribution there. We have many badged FinOps practitioners here at Azul. That's an emerging framework that is really, we're seeing a lot of badges showing up there, a lot of our customer base as well. So please check us out there. Pratik outlined our performance engineering lab. We do publish these benchmarks twice a year, typically in January or July. So there's a little bit of a screenshot of some of the data that's in the report there. And then finally, Azul Zing has been recognized as with many awards out there in the industry, notably the last couple of years as we've driven more and more adoption and published our performance results to the market. So with that
Yeah.
said, Pratik, any more parting thoughts from your perspective?
Yeah, I just want to say one more thing for those of you listening who are developers, architects, maybe you help with the DevOps stuff, maybe you do platform engineering or SRE to ensure reliable and performant deployments. You can find a nice video that I did. Well, I gave it some conferences, but it's a video that you can find on performance for Java applications. Pretty soon, I have another presentation coming out on building your own performance lab. So if this is something that you're not familiar with, or you're like, oh, maybe we should rethink how we do performance, by all means, get in touch with me or Ann or us at Azul. And you can obviously watch the video, but if you get in touch with us, myself or someone from the Azul Developer Relations team will be more than happy to come and buy you lunch if you go into the office. If you don't go into the office, we'll do it over Zoom. It's fine. We can give you some insights into how we approach performance testing, how to build performance labs. And of course, we're more than happy to look at what your specific needs are for performance testing, performance tuning. What are some of the hurdles you face? What are some of the issues you have? These are all things that we can help you with because, again, we're the JVM performance experts over here at Azul Systems.
A lot of expertise, a lot of expertise. So yes, so we're going to go ahead and conclude our session on that. Again, as Pratik had alluded to, if anything we said inspires you, please hit up Pratik or myself on LinkedIn. Make sure to download your free copy of the report and reach out to us if you have any more questions. But I would like to, I don't see any questions in the chat, but I really want to thank our participants for being a part of our session today. So thank you.
Thanks, everyone.